Hi, so here we're going to see some simple example to start learning the pthread library. So you can find those examples under the sysproc branch of the course repository, and we're going to see the example under the pthread directory. So here I put 4 code pthread1 to pthread4. So we're going to cover one by one to understand some basic primitives of the Multithread library. So let's check very simple first example, pthread1.c. In pthread1.c, here let's check the main function. So pthread1.c is to create a 2-thread beside the main thread. So whenever you create a process, there is the main thread that run the logic in a sequential way at the beginning. And you can add a more thread by calling pthread create. And at this moment of this execution, new thread is bound. It is similar to the fork, but it is very different from the fork that it does not create a new process or does not duplicate anything, but create a new control flow that concurrently learn with the current one. And here, the piece of the code that will be started on that will be run on that thread is given as a function pointer here. So let's check more detail of this function called pthread create, and it will give some pointer, one pointer of the pthread type, pthread t. This is a type of the pthread variable, and here the variable will contain some attribute of the thread. So we're gonna deliver the pointer of the pthread1 variable. Then when the pthread create function call is successful, then it return the information of newly created thread to this pointer. Okay, and I think the second argument, I forgot what was the second argument. So second argument can give us some pthread attribute if you want to give some specific property to that thread. And by default, if you don't want to change anything for that thread, then you can simply put null. And the third one is a function that will be executed for that thread. And we're gonna here put print message function, which I already defined it here, print message function. And this function is expected to have received one input argument, one function argument, which is a pointer. And by this pointer, we can deliver some data to that function. And also, the last argument here is a message. Message is a character pointer here, message1, I put. And once you put this message1 pointer here, this exact pointer will be given to this function when the thread is executing that function. So we are here giving the argument of this function call. And this function call is not executed within this thread, but the new thread will be created and the new one will execute right after it was created, print message function. And at there, this value is given as a argument, the only function argument for this function. Okay, so here we create one thread, and here we create another thread by also calling the pthread create, and we here give a new pointer because this is different thread, so we want to contain the threading information to a new one. And also things are pretty much the same, and we are here calling the same function, but we give here message as different value. So we here give a message 2. Message 1 is thread 1 and message 2 is thread 2. Okay, then beside the main function, 2 different threads are now created, and those 3 threads are executed concurrently. And here we call here pthread join. Join corresponds to the weight of the process control operation. When parent process wait for a child process, then it actually wait for any child process to be terminated, right? Join is quite similar. Join here means that the control of the calling thread, this which is the main thread, make a join with the termination of a specific child, not child thread, specific thread. We call sometimes it's child thread, but parent-child relation is more in the process. In multithreading, they're not explicitly parent-child concept, but it's all the threads that are running on the same process. So we here wait for this specific thread to be terminated. So when the thread number 1 is terminated, then the control move to the next instruction. So it will be blocked until pthread1 get terminated. Okay. And I think we put here null because we don't receive any information from the terminated thread. But if you want to receive them, you can put some pointer by which you can retrieve the return value of the threading function. And also here we wait for thread 2. Okay, and after thread 1 and thread 2 are terminated, we're gonna exit the whole program and terminate the main thread by that. Okay, and let's check the print message function. Print message function receive void pointer because it's a void because we want to receive any kind of the pointer. And depending on the logic, here the logic is to give a character pointer to the arguments of this thread function. So here we cast this pointer to a character pointer. So we call this value as a message. And what this thread basically do is iterate it over this for loop and print it out message 10 times. So let's execute this program as it is. So GCC pthread number 1. And if you give only this compilation instruction, then it will be fail because it does not find the corresponding pthread library. So in order to link the pthread library, we're gonna specify an option minus pthread. Then it will bind this pthreading, this program that uses pthreading library to actual pthread implementation that can be found in the system. Then now the binding was successful, so that building was successfully done. Let me execute this one. Edit out. And you'll see that thread 1 is executed for 10 times, and thread Q is also executed for 10 times, and program got terminated. And actually, the printing of the thread 1 and printing of the thread 2 are done by 2 different concurrent threads, yet the creation of the thread takes some time. So that thread number 1 was first created and got executed, so it quickly print out the 10 times. In meanwhile, thread 2 is created, but the amount of time that is needed for creating the thread number 2 exceed the amount of time for thread 1 to print out this message for 10 times. So thread number 1 print all the things and then got first terminated, and then thread 2 starts to print something out. So in order to see actually thread number 1 and thread number 2 are actually running concurrently, we're gonna put some delay. And let me first here put some delay by spin. Spin here means I'm simply spinning for like 100,000 times. Then thread number 1 will spend some amount of time, and in the middle of that, context switching happens. So thread number 2 will be scheduled, and it will behave some way so that we can check that they are actually running together, and interleaving between them happens. So let me execute the program in this way. So GCC, now I put option minus pthread number 1. And what I also need to put in here is minus 0. Why? Guess why? Why I put minus 0? Because in the spin loop, I made a loop, the for loop, but it does not do anything. So if aggressive optimization is applied at the compilation, then the whole logic for that meaningless loop will be removed because it does not bring any computation effect. So here I say minus O0, which means that no optimization is applied, so that the meaningless and that stupid loop can be actually executed so that CPU can spend some time on there. Okay, let me now execute this one. Then you will see that first one is executed, but at some point thread 2 is executed because spinning has some time span. So thread 2 is now created, so it now has some chance for execution. And you will see that so thread number 1 is executed, 2 is executed, 1, 2. Sometimes the thread 2 have a fortunate to execute the printing out the message 2 times within 1 quantum. Sorry. So now thread number 1 is now finished, and thread 2 contain the CPU in whole time. Maybe I execute it in a different way. I hope that there's some chance that something happens in 2 times. Yes. Yeah. Here 2, 1. And you will see that the interleaving happens between these 2 threads. Okay. And if I change the amount of time that's spent in here, so for example, I change in here, so for example, 5,000, 50,000, we compile it, then you'll see the, yes, some behavior changes in scheduling. And also, scheduling depends on the specific situation of our execution. So per execution, you will see the interleaving slightly change. So you will hear that here it has a fortunate to execute the same message 2 times within 1 time quantum, and etc. So you will here see that thread number 1 and thread number 2 are actually the one that runs concurrently. And let me slightly change this example by muting the spinning yet turning on the schedule yield. This is a special instruction, so let's check the effect of this example. And you will see that thread 1 is executed, and then 2, 1, 2, 1, 2, and they are alternating. You also execute this one again, then you will see that 1, 2, 1, 2 are alternating. So here, schedule yield operation voluntarily pass the control to another concurrent thread. So usually context switching happen in a preemptive way. Preemptive way means that scheduler forcibly take the control of the CPU of that is assigned to the thread and give it to another thread. But yield operation is some operation that voluntarily yield the CPU contended by the current thread to give it to another thread, so that thread number 1 is executed, and after printing out one message, and it pass the control to another thread. So another thread is also executing the print message function, but difference here is the message is now thread number 2, so it executes one statement, and also it executes the schedule yield, so the control comes back to the first thread and execute the thread number 1 and yield, so it executes the thread number 2 and yield, and so forth. So messages are alternating by scheduling yielding operation. So this is the very first example. I think this is the most simple example that create a thread so that threads are running together. And one thing you know here is that the main threads are waiting for them to terminate it. This is the very basic example of the pthread.